To find out just how fast light does travel, I'm going to send light on a very long journey. Longer than this, longer than this, longer than this. I'm going to send a beam of light into space. This is no ordinary beam of light. This is a laser gun. It will fire a very intense beam of light, laser light, up into the air. The light is so intense that once fired, it can travel thousands of kilometers into space. The light will travel to a satellite, thousands of kilometers away. How will we know when it's got there?
Believe it or not, this is a clue.
A disco mirror ball? What's that got to do with it?
Roger Wood, a scientist at the Hertzsprung Satellite Laser Ranging Base, revealed the connection.
This is actually remarkably like a real satellite.
Yes, satellites can be as small as that.
Well, some are even smaller, but this is a typical sort of size. And in real satellites, the flat mirrors that you see here are replaced by retroreflectors.
Ah, retroreflectors. So that means the beam of light that actually arrives at the satellite will reflect directly back down the same path.
That's it.
At least I've learned something.
The laser light bounces off the satellite and reflects back down to Earth. Not just anywhere, it's going to come back right here. This is a receiver which signals when the light returns. The precise position of all satellites is calculated by a computer. This computer graphic shows their orbit, so we know exactly when they're passing overhead. At 9:30 tonight, a satellite called Epsilon is going to pass over us, and our laser beam's going to get it. The light is going to have quite a journey. To Epsilon and back is 40,000 kilometres. Nearly 9:30. Here it comes, and it's off. Woo! There it goes on its 40,000 kilometre journey. Right, Rog, how long do we have to wait for it to come back?
I've got news for you. Come and have a look downstairs.
Okay. Of course, when you see a laser beam, you're not seeing the laser itself. What you're seeing is the laser light reflecting off dust and water droplets in the air.
So we've got equipment here that can measure precisely how long it takes for a burst of laser light to get from here to the satellite and back again.
But the big question is, how long does it take?
Well, it's about 1/7 of a second.
Wow, 1/7 of a second to travel 40,000 kilometres.
That's right. And you can get a very vivid idea of how long 1/7 of a second is by listening.
These clicks are 1/7 of a second apart, and in that time, light can travel the same distance as once around the world. That's fast. In fact, the speed of light is an amazing 300,000 kilometres per second. But you know, it's not just laser light that travels this fast. All light travels at this incredible speed, even the light from my humble torch.